Madelung constant. Formation energy of a molecule is calculated via cohesive energy, the lattice energy. Typically, in case of the ionic crystal, let's say we have two molecules A and B having the charge a positive, I mean to say when they form a new molecule AB, and assume that your A molecule is having the charge Z plus, another molecule has the charge of Z minus. So Z plus E with the charge on one of atom if they are separated, and Z minus B, Z minus E for the another one in case of negative ion. So what will happen in this case? They will try to form a ionic crystal. There will be an electrostatic force in between them, and that force, will be then given as the product of charges upon 4 pi epsilon naught R naught, where R naught is the distance between the adjacent ion, and in present case it is the lattice constant, maybe, if this is the crystal. So this is your potential energy, electrostatic potential energy. Understandable? But normally you understand it's nothing to do with the only two atoms. There will be more atoms also, and they will arrange in 3D. So because of these arrangements, this electrostatic potential energy will be altered, and that alteration is denoted by a constant called alpha. And this alpha, one thing is that this alpha plus this makes a lattice energy. In case of ionic, we can say at least. So that is called the lattice energy. The formation of this molecule occur via lattice energy, which is purely electrostatic in the nature in case of ionic crystal. So that's a U, right? Alpha is the Madelung constant. So what is Madelung constant? So Madelung constant is a dimensionless quantity which is used to calculate this U for an ionic crystal. Remember the word, I am keeping the word say ionic crystal because in another crystal it will be something different. So alpha represent the sum of all kind of interaction, Colombian interaction, just in the a scaling factor. So it is only a correction factor, or rather scaling factor for the this electrostatic interactions, right? Remember that this alpha depend only on the geometry of the lattice, nothing else. Now let us see how it can be calculated for 1D system, because we understand this depend on the geometry. So there may be 1D, 2D, 3D, the natural one, 3D is there. So we'll start first thing with the 1D only. And in case of 1D, we will take the example of sodium chloride, which has the alternative pattern of positive, negative ion. So we are considering 1D sodium chloride crystals. So you know that it has a positive charge and negative charge, and all have the amount of the charge is the same, like say 1e, but the nature of the charge is opposite. On sodium it is plus, on chlorine it is negative. So and they are separated by a distance, and this length go to infinity here and up to infinity here. So for the calculation purpose, we take in the middle a reference ion. This is our reference ion. So we have a series of alternative arrangement of atoms in this side as well as on this side. So what you require? You require to calculate the alpha, because we are knowing what is the U, because Z1 and Z2 is 1. So E square becomes very simple. 4 pi epsilon naught is there. But what is not is there is the R naught alpha, that we have to see. Now, if you are going to see how this alpha is occurring, you can understand that if this is happening for the first atom, let's say, I'm talking about only one part, then its distance is R naught. So it's something by minus, leave this part. separate. I'm only talking about this and this. So R naught is there. So R naught is there. 1. So 1 minus is minus. So it's a 1 by 1. Now we are moving from here to here. Now the distance is what? 2 R naught. See here. So 2 R naught. So here is R naught now become 2 R naught. So here it is 2 now. R naught I am leaving here. Only 2 I am taking in this part. Then you have next. So you have 3. In the similar way you have 4. And depending on that, plus, 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 minus, minus, plus, minus. You understand? When this is minus, this is plus, so minus. This is plus, this plus will combine with this, then it's a plus. So it's a minus, plus, minus, plus, and this is alternative series with the value of this. Now this is a very similar thing. Whatsoever will happening here will happen on this side also. So what will happen? That's it. We have the alpha twice. We have the twice alpha there. Now you see this is an alternative series. So well known, one of the relation is there that the natural log 1 plus x equal to this. So replace this x with 1. What you get? The same thing you will get. Only thing is that negative sign is there. So we will take the negative side outside. So in that case, this will become alpha become minus outside 2i's for 2. And this is your natural log of 2. And the value of that is about of 1.386. And this approximation, because this is a series which is going to be converged somewhere, that's why it's always give the approximate value. So what is alpha for the 1D NaCl crystal? It is 1.386, right? It is different than 2D and 3D, which is slightly bit higher. It's a minus 1.386. So once you know the alpha, so you can understand how we do this one. This is a series particularly, so we can put this thing into this summation way. The alternative way how to represent this number is this one. So you can use that one and you can get the final result for the lattice energy, or you can say the electrostatic potential energy for 1D crystal. Remember that for different kind of crystal, this alpha part, which is this one, is going to alter. So this was the Madelung constant for 1D NaCl crystal. Thanks for watching this video.